Welcome to the second video in our series on cost volume profit analysis. In this video, we will be looking at the mathematical approach to CVP analysis. Our learning objectives for this video are to first understand the development of the break-even formula. This is important as when calculations get tricky, it often helps to take a step back and begin with the initial profit formula. Next, we will learn to calculate and interpret the margin of safety. Finally, we will apply the break-even and margin of safety formula to advanced situations such as target profits and sensitivity analysis. You should remember from part 1 of the series how we developed our break-even graph. The accounting view is very different. The accounting view on screen is very different to the economist's, and that is because we make 7 key assumptions to simplify reality. As we approach deriving the break-even formula, I want to highlight assumption number 5, that profits are calculated on a variable costing basis. Under variable costing, net profit is a function of sales only. We could also simplify our break-even graph into the profit volume graph. This graph is very important as it shows a single line representing our profits, which is our revenue less our total costs. So based on this, we begin with our total profit equaling total revenue less total costs. We can then break up our total costs into their variable and fixed portions. We can also break down our total revenue into the selling price per unit multiplied by the number of units sold. We can do the same for our total variable costs. We then group our selling price per unit and variable cost per unit together, and we know that this gives us our contribution per unit. So we end with our variable costing profit equation of net profit equals contribution per unit multiplied by the number of units sold less our fixed costs. With this formula in mind, we know that by definition, the break-even point is when our profit is equal to 0. Thus, we can substitute 0 in for our profit. Now we rearrange the terms to get units by itself on the left-hand side of the equation. This gives us our break-even formula of units is equal to the fixed costs divided by the contribution per unit. Now the break-even formula we have derived will give us our break-even point in units sold. To get our break-even sales revenue, we can take our break-even units and multiply them by the selling price per unit. There is, however, an alternative break-even calculation, which will give us our break-even revenue directly. This is to take the fixed costs, and instead of dividing them by the contribution per unit, we divide it by the profit volume ratio, also known as the contribution margin ratio. The profit volume ratio is calculated as the total contribution divided by the total sales. Once we have calculated our break-even point, we can then calculate the margin of safety. The margin of safety is a measure of risk. It tells us by how much our sales can decline before we break even and start incurring losses. To calculate the margin of safety, we simply subtract the break-even sales from the actual or budgeted sales. This can be done for either sales units or for sales revenue. The margin of safety percentage is then just the difference between our actual or budgeted sales and the break-even point, all divided by the actual or budgeted sales. Now let us look at an example to see how the mathematical approach to CVP works. Pause this video and take a moment to work through the example on screen. When you are ready, unpause and we will work through it together. Great. So hopefully you have worked through the example and have your answers ready. Our first required is to calculate the number of pairs of shoes to be sold per annum to break even. For this question, we can simply apply our break-even formula. There are 2 tricks, however. First, we are asked for the number of pairs of shoes. The scenario gives us the selling price per pair, but the variable cost per individual shoe. The second trick is that we are asked for the number of pairs per annum. Our fixed costs, however, are presented monthly. To accommodate these two issues, we need to take our monthly fixed costs and multiply them by 12 to get the annual fixed costs. To get the variable cost per pair of shoes, we need to take our cost per individual shoe and multiply it by 2. This will give us our break-even units being equal to 1,200,000 Rand and our contribution of 50 Rand per pair of shoes. Therefore, our break-even point in units is 24,000 pairs of shoes. It is always important to remember the unit of measurement we are working with. In this example, it is pairs of shoes. The second required then introduces the idea of a fixed target profit. A fixed target profit is a profit that does not change with the number of units we sell. Let's start with our profit formula and see how we will treat a fixed profit. So we begin with our full formula, and this time we keep the net profit term and we rearrange the terms so that the number of units is by itself on the left-hand side of the equation. When we do this, we see that our net profit is added to our total fixed costs. Therefore, we can conclude that we treat a fixed target profit in the same manner as a fixed cost. With this knowledge, we can now calculate the number of units to be sold in order to achieve a profit before tax of 100,000 Rand. Again, our fixed costs are the 100,000 Rand multiplied by 12 to represent the full year, but we now add the extra 100,000 Rand target profit. Our denominator remains the 100 Rand less the 50 Rand. Therefore, we need to sell 26,000 pairs of shoes per annum to achieve a target profit of 100,000 Rand. Our next required is to calculate the number of pairs of shoes to earn a profit after tax of 35,000 Rand. Again, we have a fixed target profit to be achieved, so we know that we must treat it like a fixed cost and add it to the numerator in our formula. However, notice this time that the target profit we are given is after tax. Therefore, we first need to gross up the target profit to determine our profit before tax. To do this, we can take the net profit after tax and divide it by 1 minus the tax rate. This will give us a net profit before tax of 50,000 Rand. Now we can apply our formula. We get 100,000 Rand multiplied by 12 months plus the 50,000 Rand all divided by the contribution of 100 Rand less 50 Rand. This gives us an answer of needing to sell 25,000 pairs of shoes in order to earn an after-tax profit of 35,000 Rand. Our next required is a bit different. Here we are told the number of pairs of shoes and our target profit. This time, we need to calculate the selling price that will achieve this. To answer this question, we will begin with our net profit formula. We will then split the contribution per unit into its components of selling price per unit and variable cost per unit. This step allows us to isolate the selling price, which is what we are trying to calculate. We can then enter the information. So we have our net profit of 100,000 Rand, our variable costs of 50 Rand per pair, our units of 30,000 pairs, and our fixed costs of 1.2 million Rand. Now we can calculate our missing variable of the selling price per pair to arrive at 93 Rand and 53 cents per pair of shoes. Our next required goes back to the concept of a target profit that needs to be achieved. However, unlike required 2, we now have a variable target profit rather than a fixed target profit. Remember, our fixed target profit is a constant number, such as 100,000 Rand or 35,000 Rand. The target does not change with the number of units sold. A variable target profit, on the other hand, is not a constant number. Rather, it is commonly expressed as a percentage of sales, and therefore it can change based on the number of units sold. So here, our target profit is 10% of sales. Because sales can vary, it is considered a variable profit target. To answer this question, we will start with our profit formula. We will now restate our net profit as 10% of sales. So we end up with the selling price per pair multiplied by the number of units sold to give us our total revenue. We then have to multiply this by 10% to represent our target profit. Now we can manipulate this formula to isolate units on the left-hand side of the equation. What we see then is that we need to subtract the variable profit target from the contribution per unit. So in essence, a variable profit target is treated in the same manner as a variable cost. We can now proceed to input our numbers. Our units is equal to the 1.2 million rand divided by the 50 rand, which was our initial contribution, less the 10% of 100 rand. This equals 40 rand as our denominator. Therefore, we need to sell 30,000 pairs of shoes to achieve a profit of 10% of sales. Our last required is to calculate the margin of safety if our sales are budgeted to be 25,000 pairs of shoes. Here, we can simply use our margin of safety formula. We know that our budgeted sales are 25,000 pairs of shoes, while our break-even sales from required one was 24,000 pairs. This then gives us our margin of safety ratio of 4%. This means that our budgeted sales can drop by 4% before we begin incurring losses. Importantly, this margin of safety calculation could also have been performed using sales revenue rather than sales units. This is important when we look at our next topic in the series of multi-product CVP analysis. The examples that we have considered are a mere sample of the power of CVP analysis. Make sure you expose yourself to more examples to fully understand CVP. This brings us to the end of our video on the mathematical approach to CVP analysis. So far, we have only considered the situation of a company producing a single product. In our next video, we will introduce the idea of performing CVP analysis with multiple products. See you next time.